Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's presentation on correlation part 3. In the last session, we have discussed about correlation coefficient and the methods to find correlation, and the properties of correlation coefficient. And then we solved some problems on finding the correlation coefficient or when the means are integers. So that means if x bar equal to 24, y bar equal to 32, which are whole numbers. So we use the formula R equal to sigma capital XY by under root sigma x square minus sigma y square to find the coefficient of correlation. Now, in today's presentation, we find the coefficient of correlation, the value of R, when the means are not whole numbers. If the means are not whole numbers, that means, for example, if x bar is 27.6 and y bar is 120.3. So, which are not whole numbers. In that case, we cannot use this formula. So, we use a different formula, and again that formula was also proposed by Karl Pearson's. So, Karl Pearson's coefficient of correlation. In today's class, we are going to find the correlation coefficient when the means are not whole numbers. When the actual mean of x and y are not whole numbers, that means if x bar and y bar are some fractions, then by Karl Pearson's coefficient of correlation, the value of R can be calculated using this formula R equal to sigma capital X into capital Y minus sigma capital X into sigma capital Y divided by n whole divided by, now this in the denominator we have product of two values. One is under root sigma x square minus sigma x whole square by n and under root sigma y square minus sigma y whole square by n. So, we use this formula when the means are not the whole numbers. In that case, we consider assumed means denoted by A and B. Now, how to consider those assumed means? For example, if x bar is 27.6, so the value after decimal, this value is greater than 5. So, we consider the assumed mean A as the next value 28. Similarly, if y bar is 120.3, now here this after decimal value, this is 3 which is less than 5. So, we consider the assumed mean as the previous value 120. Sometimes, for example, if x bar is some 32.5, then we can take any one of those two values, either 32 or 33 as the assumed mean. So, when the means are not whole numbers, we consider the assumed means and use this formula to find the correlation coefficient. And here capital N is the total number of given items, and A and B are assumed means of x and y values. So, simply the procedure is the same, just the formula changes. Whatever values are required to find those values, we construct a table, and first we transform small x to capital X and then small y to capital Y, then find all the required values and substitute in this formula. Let us solve one problem on assumed means. Calculate the Karl Pearson's coefficient of correlation for the following data. So, here the first row denotes x values and the second row denotes y values, and first total number of values given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, given total number of points, capital N is 10. Then, first we need to check whether the means of x and y values are whole numbers or not. So, the mean x bar is sigma x by n. So, 28 plus 41 plus so on plus 33 divided by total 10 values. So, here this answer is 355 divided by 10. So, 35.5. Similarly, let us calculate the mean of y values, y bar, sigma y by capital N. So, 23 plus 34 plus so on plus the last value is 38 divided by 10, which is that sum of the values in the numerator is equal to 313 divided by 10, which results as 31.3. Now, here it is very clear that x bar is 35.5 and y bar is 31.3, which are not whole numbers. Not whole numbers. So, therefore, we consider the assumed means for both x and y values. Assumed means. I will take the assumed mean of x values. X values is capital A. So, 35.5 we can take either 35 or 36, any value is accepted. And assumed mean of y values B equal to 31.3. So, we will take the previous value 31. Now, we use this capital A is 35 and capital B is 31 to convert small x and small y to capital X and capital Y. Now, here A equal to 35. So, capital X is small x minus 35 and capital Y is small y minus 31 since B is 31. Now, these are the values of x, given values, and we need to convert this small x to capital X using this x minus A. So, x minus 35, 28 minus 35, 41 minus 35, like that we convert small x to capital X. So, this is minus 7, minus 6, minus 5. So, we convert small x to capital X using this x minus 35. So, 28 minus 35 minus 7, then 41 minus 35 6, 40 minus 35 5, 38 minus 35 3, this is 0 and minus 2, 40 minus 35, 32 minus 35 minus 35, again minus 2. Now, if we add all these values, so this is minus 7 minus 10 minus 14 and 11 14. So, cancel. So, now we square the values of capital X to find capital X square. So, this is 49, 36, 25, 9, 0, 4, 25, 9, 0 and then 4. Similarly, let us convert small y to capital Y using this small y minus b. So, b is 31. Here 23 minus 31. So, minus 8, this is 3, 2, again 3, minus 1, minus 5, minus 3, 31 minus 31, 6 minus 1, 5, 7. Now, square these values 64, 9, 4 and then 9 again, 1, 25, 9, 0, 25, 49. And now we need to calculate, so product of these two values capital X and capital Y. So, this is 56, 6 into 3, 18, 10, 3 into 3, 9, then 0, then 10, minus 15, again 0, 0 and minus 14. And these are the totals, and here since the means are not whole numbers, we are using a different formula, R equal to sigma capital XY minus sigma capital X capital Y. So here we need all those values, sigma capital X, sigma capital Y, sigma capital X square we need, sigma capital Y square also we need, and then sigma XY. So let us calculate all those values by constructing this table and by adding all such values. So here this is sigma small x, this is sigma capital X, sigma X square, sigma small y, sigma capital Y, and sigma Y square, and this is sigma XY. So here sigma capital X is 5. Now let us use the formula to find the coefficient of correlation, R equal to sigma x into y minus sigma x into sigma y by n under root divided by under root sigma x square minus sigma x whole square by n multiplied by sigma y square minus sigma y whole square by n. So by substituting these values, so here sigma xy is 79 minus sigma x is 5, y is 3 divided by 10 whole divided by under root sigma x square is 162 minus sigma x whole square 25 by 10 multiplied by sigma y square 195 minus sigma y whole square 9 by 10. So by simplifying this, we will get 0.45. This is the correlation coefficient between the given variables. Similarly, let us solve one more problem. Calculate Carl Pearson's coefficient of correlation, the following data. So fertilizers used and productivity. So the first row corresponds to fertilizers used. Let us denote it by small x and productivity by small y. Now how many values are given? 8 values are given. Total number of values given. Total number of values given is capital N is 8. Now first we need to find the mean x bar. The mean x bar is sigma x by n. So 15 plus 18 plus so on plus 50 divided by total number of values 8, and this is equal to 232 by 8. And the result is 29. And similarly, the next mean of y values sigma y by capital N is 85 plus 93 plus so on plus 160 divided by 8, and the numerator is equal to 938 divided by 8, which results as 117.25. Here one of the values is a whole number, but the other is not a whole number. So even a single value is not a whole number. We use the second formula. So here for x, no need to consider assumed mean. We can take directly x bar as 29 itself. But for y, the assumed mean b is 117.25. So we can take the assumed mean as 117. So x bar is 29 and b is 117. This is the assumed mean or the actual mean for x values. We can consider it as x bar, either x bar or a. So 29, 117. Now this is x minus 29 and this is y minus 117, and these are the leftmost column x values. We convert that x to capital X using x minus 29, then square the values. Similarly, y, capital Y, square the values of y, and finally the product of x and y values. So, here the totals are given in the last row. So, this is sigma small x and this is sigma capital X. Here sigma capital X is 0 because we are using the actual mean 29 itself. So, the sum of the deviations of the observations from the mean will be always 0. If we are using assumed mean, we won't get 0. So, here sigma capital Y is minus 14. Here sigma capital X is 0 since the x bar is the actual mean itself, whereas here minus 14 since B is the assumed mean. And similarly, we calculate the other values, and using the Karl Pearson's coefficient of correlation for assumed means, the formula is sigma x into y minus sigma x into sigma y by capital N divided by square root of sigma x square minus sigma x whole square by capital N multiplied by sigma y square minus sigma y whole square by capital N. Here the formula is simple, no need to by heart, simply try to understand the format of the formula. So, here sigma capital X into y, product of the two values, minus product of individual values divided by n, that is the numerator. Sum of the products minus product of the sums divided by n, that is numerator. In denominator under root, here sum of the square terms minus sum of the single terms square of the sum of the single terms divided by n. So, sigma y square minus sigma y whole square by n. This is sum of the squares minus sum of the actual values whole square by n. So, by substituting all these values, sigma capital X into y is 2317 minus sigma x into sigma y, sigma x is 0. So, this becomes 0. Under root sigma x square 1022 minus sigma x whole square, again 0, and sigma y square is 5368 minus 14 whole square by 10. So, after calculating, the value of R is 0.99. So, that means the two variables x and y are almost strongly correlated. The correlation is positive and perfect since the value is almost equivalent to 1.99. That means the fertilizers used and the production both are in a strong relation. The correlation is perfect and positive in the present problem. So, like this, we calculate the coefficient of correlation for the given data. In today's session, we have solved some problems on correlation coefficient when assumed means are considered. Now, when we consider assumed means, if the actual means x bar and y bar are not whole numbers, if they are not whole numbers, then we consider the assumed means, and we use a different formula to find this correlation coefficient, which was proposed by Karl Pearson. In the next session, we will discuss about the rank correlation coefficient. Rank correlation. So, the correlation coefficient can be calculated by assigning ranks to the given observations. So, that topic we will discuss. We will meet in the next class. Thank you very much.